Geared rocket. Test kind of went well, got a lot of insights from that. Now we're taking what we learned from the fluid analysis and the gyroscopic stability analysis and applying that to the third rocket. That's the direct drive rocket. That one's currently in production right now. Ordering parts, stuff is shipping, so we can do a lot of design work in the background. But it also makes a lot of sense to try and get more data out of the geared rocket system because we only have one test. So in order to run more tests with a geared rocket, we're gonna have to take apart the arm, get it set up again. Let's check it out. This barrel here is responsible for that launch that we have from the last video. What I think is gonna be pretty cool is that we're actually gonna put the new design in the right barrel. So that allows us to potentially have a design where we can have, the old rocket design and the new rocket design in the same forearm and even compare performance like back to back. Also, you notice we have the bicep right here. The bicep is something I rarely put on the arm unless I'm trying to wear it or do something. We're actually gonna need to remove the bicep in order to take apart the rocket barrel, so we'll do that. A fun thing to note about the bicep is gonna be these actual elbow covers here. They're more of a decorative piece, not necessarily super functional. You can see as I rotate the actual bicep, that piece is actually coupled to the forearm, and the bottom piece is coupled to the actual bicep itself. We successfully removed the bicep and actually the elbow covers as well, but you can see there's a little bit of like mechanical design going into the actual hinge joint here. There's not a lot of subsystems in the bicep like the forearm has. That one's loaded with all these different subsystems, the rockets, the flamethrowers, the blade, right? So that makes sense to be in the forearm, but it also allows us a lot of space and freedom to explore more of the mechanical design behind the actual assembly around myself. In Iron Man, he has a suit that assembles around him, all these kind of cool internal mechanisms that accomplish that, and with the bicep, we can actually do that because of the space that we have, and that's kind of where the design is going there. All right, so we're gonna put the bicep to the side now, get this guy out of the way. Now we can really take a look at kind of where all the magic happens, which is gonna be the forearm here. The main thing is we need to get to this barrel, right? So there's a lot of things going on that's still preventing us from getting there. The main thing is gonna be the actual elbow joint, which houses the laser. It's an important mechanical point for the actual suit functionality. You can see we have our supination and pronation capabilities here. That basically allows my forearm to twist. In the actual human body, it's pretty cool. That mechanism is actually taken over by your forearm bones twisting over each other, whereas in an exoskeleton, you have to actually match that rotation with some sort of mechanism and also couple that with your actual elbow joint bending. Our elbow flexion and extension that happens at these points here, that actually also needs to be pretty closely tied to the actual pronation and supination that we see there. This capability is pretty important for an actual exoskeleton to match my movements, especially when we power it in the future. We kind of want to lay down the groundwork for all these kind of degrees of freedom that the human body has so that we can later just actuate on them and not have to worry so much about redesigning the entire kind of mechanical outline of the human body. So we got the elbow off. What's cool is that there's this little retaining ring there that actually prevents the elbow from popping out of the forearm while also allowing for rotation. All the force from any sort of impact on the actual forearm gets transferred to here. So this obviously needs to be a strong part. It's aluminum, we're gonna make it titanium, and then we should be okay for a while. Now looking at the actual structure of the piece itself, it's designed a little bit like a bearing. You can think of these little balls here that are all free spinning, reduce the friction as it makes contact with the inside of the forearm. There's a lot of electrical connection problems that are solved with the actual elbow design, so we'll take a look at those in the future too, because those are pretty cool. You can see the laser sticking out the back there. That's what we use to ignite our rockets, and we're gonna have to check that out in a second. What's cool is we can easily just kind of pop it out like that. Nothing too crazy. So now we need to actually take this barrel off here. This barrel here is actually also mounted. You can see the old blade is on there too. That's what I did those old side blade tests with. And those worked pretty good. It just doesn't make sense to have all these systems enabled right now when I'm just trying to focus on one. So we were able to take this guy off, and you can see the linkage and the sensor that we talked about back then. Take a look at what's underneath. You can see these two pieces here. These are a couple of just huge bearings that I used to actually allow the rocket to spin a lot more freely. It's just meant to lower the friction of the rocket spinning and allows it to spin a little bit faster. So that's what those are for. A couple of things you're probably gonna notice is gonna be these actual rails here. These are actually flexible PCBs. They're kind of used in a lot of electronics nowadays. Your phone definitely has them inside. The main thing is that they allow me to unlock a very tight routing form factor throughout the forearm so that all these wires that you see here can actually be just consolidated into this very thin strip of paper and still get the same level of like electrical density that I want. That's kind of the new standard for the wire routing on the suit. It's unlocked a huge level of compactness that was not previously accessible. Before we keep going, another thing I want to quickly mention is the actual bottom forearm. So this part doesn't get a lot of love, but the cool thing now is that it's a lot more responsible for housing most of the important electronics that actually control the forearm. So if we look at the base here, you're gonna see there's actually these 3 power stages. There's supposed to be a 4th one there that's actually 3.3 volts. That's gonna be our lower level logic power, but that one's getting a redesign because it's not working as expected. So looking at the other ones, this is kind of just taking in our main power here, which is coming from our battery pack, and that's gonna get downgraded to a bunch of different voltage rails, like 14.8 volts, we have 12 volts here, and we have 5 volts. Those kind of 3 different voltage rails is gonna give us kind of the primary access to what a lot of our components are gonna need. But the main thing there is that these actually feed as well into our microcontroller. If I had to have a bunch of different inputs for a bunch of different voltages, I'd have to have all these wires coming from the chest piece to the bicep to the elbow and then to the forearm. That's also why I decided to go with the ESP32S3. You know, that one has Wi-Fi and Bluetooth communication. So instead of having to route all of my signal wires back to the chest piece, you just communicate wirelessly with each subsystem on the forearm, send your commands over. One more thing that's super cool about the bottom forearm is these connectors here. So not only do we have our flexible PCB routing kind of components, we also have these magnetic connectors that allow me to disconnect the actual forearm itself electrically. Basically, it's just a magnetic snap fit. And that works super good in terms of transferring electrical connections reliably. You're probably thinking that that is not a very strong kind of connection mechanism, which is why it's super easy to take off. And that's probably not gonna be useful for an Iron Man suit that I'm wearing, right? So that's where this whole other subsystem that I kind of briefly mentioned with the bicep comes in. And that's kind of what we have, the donning system. That whole system will take care of the actual mechanical mounting of the forearm. For now, temporarily, the electrical connection kind of doubles as a mechanical and electrical grounding point so that we can actually put the forearm on, do our tests, and not have to worry so much about having a whole nother subsystem working just to do our tests. So now we're gonna look at the actual barrel itself. And this is kind of where a lot of the actual rocket electronics are. A lot of the motor controllers for the flap here and the actual sensing mechanism for the flap is actually housed in this little piece here. So if we take this guy off, you can see we have a couple of PCBs hanging out underneath that little piece there. This one here is going to be one of our Hall effect sensors that we use to detect the magnet in the flap there. But this kind of unfoldable PCB, I mean, it's technically 3. It's our bottom, our connector PCB, and our top PCB. The actual function of these components is meant to drive this motor here. So this is just a motor driver that I designed to be kind of flipped over on itself like a sandwich. You can see it's kind of 3 separate components connected through the back, and these components are actually using these little connectors here. Those are meant to connect your very low profile kind of flexible PCB cables together instead of having to use big bulky connectors that defeat the whole purpose of having a low profile kind of routing system. If you take a look at the underside of this piece, there's also a little bit of the gear train mechanism that we use to spin up our rocket that's being housed in here. So we have our motor output, our intermediate gear train, and then our output gear train. And this is what drives our rocket, is this actual output here. So now we can go ahead and take this guy off here, and you can see the actual routing piece there. There's a little iPhone connector type cable, and that's a tachometer. That's the actual sensor that is shooting a little infrared laser beam through the actual side of the barrel and then into the side of the rocket. So we can actually tell the microcontroller when to launch. But one last thing I want to mention that's pretty cool. This is magnetically connected, as you can see, to the forearm itself. Magnetic connector is definitely the best. You can see some there, and then those are the kind of mating pieces there. And there's a little metal brace there that just kind of helps with the connection. You notice these 2 pieces here are also metal braces that help with the actual intermediate connection between these 2 parts. We obviously don't want them kind of ripping apart or bending or anything. Kind of an extra level of a brace there. This is the actual input gear coming from our motor that drives the entire gear train that controls the rocket. So pretty important part there. And then you can actually see our laser exposed underneath. This guy shoots straight through here into the back of the rocket, igniting it and shooting out that barrel. So kind of the last important piece there. One thing I want to mention that's kind of annoying with the laser and the motor to drive the rocket is that they're both using kind of off-the-shelf components. You can see the brushless motor driver there, and you can actually see the laser driver here. You'll notice that because I had to buy them, they're not super kind of seamlessly integrated into the forearm. That's actually going to be one of the main points of the next rocket videos, is actually going to be the redesign of the laser driver. It's super useful in terms of getting a repeatable design that I can then customize to the actual forearm itself. Instead of having to worry about an off-the-shelf part that I have to buy every single time I want to use a laser. So that kind of covers the breakdown of the Mark II arm, mainly looking at the rockets. We talked about a couple of other subsystems that we're definitely gonna have to do video series on in the future, but for now, that's kind of the main hardware design choices that went into getting the arm to work, at least for the test that we did last time, right? This is a new kind of format for the videos I've been doing. Might be a little bit of a different format than what you're used to, so if you kind of like it, maybe you don't like it, let me know, because that'd be good feedback. All right, see you guys later.